Okay, for 9.4, we are starting one of our 3 true trig ratios. Excuse me. So you should have 3 trig ratios that we're going to have learned by the end of this chapter. We're starting with our first one, and it is tangent. So whenever you're looking at your calculator and you see sine, cosine, and tangent, these 3 buttons on your calculator, wherever they are, we're going to do tangent today. Sine and cosine are coming, but tangent, we're just going to start with, I think, the easiest one. So the first thing I want to know is, are these 3 triangles similar? Our previous lesson, we learned about taking the 3 triangles and separating them into 3 similar triangles. So are these 3 similar? Obviously, we don't know the height of the tree or the person, if that's a person, or the ant, but we do know that the acute angle is 38, 38, 38, and they all have right angles. So that is enough information to be able to say yes, because there is something that we've already learned that's called angle-angle similarity. And if you have 2 of the same angle degrees, then that means you have the third one. And if all 3 angles are equal, then they are all proportional. So we are going to say yes based on angle similarity, and that's what that means. So angle similarity, if you would like to write out that 2 of the angles are equal, you can, but that's what angle similarity means, and we've already learned it. Okay. Before we get into the specific tangent ratio, you should probably first know what a trigonometric ratio is. So a trigonometric ratio is a ratio of side lengths. So your calculator, it has these fancy buttons that actually have the ratios of side lengths of right triangles kind of built in. So the side lengths, it has to be, speaking of which, it has to be in a right triangle. So we're going to get into some trig where it's not a right triangle, but for the first lots of practice lessons, they're all going to be in right triangles. So it has to be in a right triangle with respect to, here, we'll just write this, with respect to one of its acute angles. To one of its acute angles. So here's something really important to remember. When we're using trig ratios, we're never using the right angle. So, and if you think about it, if it has a right angle, can it also have an obtuse angle? No, it cannot, because if it has a right angle in a triangle, then the other 2 must be acute to add up to 180. So we're talking about one of the 2 acute angles. So when I say like find an angle you're going to use, you can't ever use the right angle. Okay, we're always going to use one of the 2 acute angles. So it should give us one, and you can easily calculate the other. Think about how you would calculate the other. If we know one is 90 and we know they add up to 180, you just subtract 90 and 38 from 180, and whatever's left becomes your other acute angle. So when we talk about trig ratios, we're talking about one of the acute angles in a right triangle. So something important to remember. All right. Tangent of a 38-degree triangle. So sometimes it might be just that easy. The tangent ratio, the ratio of a 38-degree angle. We're just going to push the tangent button. Tangent. Mine automatically, when you push tangent, opens a set of parentheses. So that's where I'm going to put my 38. If that's the only thing you put, you don't have to close the parentheses. But if you're going to put times 12 or something later, then you do have to close the parentheses. But if all you're putting is tangent and a number degree, then you don't really have to close the parentheses and you'll still get the same answer. So the tangent of 38-degree angle is equal to 0 point, and usually we go 4 digits out. So anytime you're using trig, it's really specific to use as many decimals as you can, but it usually works best if you use 4. So we're going to say 0.7813 because that will give us our 4th decimal place value, and the 8 will round it up to a 3. So the tangent of 38 degrees ends up being a ratio that comes out to be 0.7813. Okay, and we'll get into more of like, what does that mean later? But for now, let me talk to you about the tangent ratio. Okay, so the tangent ratio is a ratio of the length of, okay, this is specific to tangent, and that's the only one we're learning for today. The length of the opposite side. So whatever angle they're talking about, you're going to go find the opposite side. And I'm going to make sure you know which one is the opposite side. To the length of the adjacent side. To the length of the adjacent side. So you're going to need to become familiar with words like opposite and adjacent, and I need them to make sense. So tangent of angle A. Which one is my opposite? Which one is my adjacent? So I'm going to put opposite side over adjacent side. And we're actually going to find those in, let's use this middle, kind of big one because it's a little easier to see. So, oh, we can't because it doesn't have A. Oh, A is here. So we'll just make this XA for now for this. So here's angle A. It's our 38-degree angle. Here's angle A. I need to know the tangent of angle A, and anytime you're using the word tangent, you have the opposite over the adjacent side. So let's find the opposite of angle A. So look at where A is. Opposite is like if you follow angle A out, it's the opposite of it. It's right here. So opposite is directly across from it. So that is ZY. So side ZY is our opposite. ZY is opposite. Adjacent is the one right next to it. Well, a lot of kids ask, well, wait a minute, this one's next to angle A, but so is this one. So which one's the adjacent one? It's never going to be the hypotenuse unless it says the word hypotenuse. So since this one doesn't say HYP hypotenuse, it says adjacent, then we are not going to use the hypotenuse. We are going to use the other one. So once again, we used opposite, which is XY, over adjacent, not hypotenuse. So this is AY. Okay, again, this will make more sense when we actually do like sine and cosine, because those sometimes say hypotenuse. But since it's just opposite versus opposite over adjacent, we're just looking for the side that's opposite it over the other leg, basically, is what adjacent means. The other leg, not the hypotenuse. Okay. So let's find these tangent ratios. First of all, we're not looking at B at all, so we're just looking at A. The tangent of angle R, remember tangent is opposite over adjacent. So find R. Opposite R is 18 over adjacent. Which one's adjacent? It's not the hypotenuse. So it's the other leg. So 18 over 80. I do think you're going to have to always simplify if that's possible. So 18 over 80, since we're leaving it in ratio form, I still want you to leave it a fraction, but we're going to simplify it. So 18/80ths, I don't even know, is 9/40ths. I love that your calculator will simplify it for you. If you're not sure how to do that, instead of pushing divided by, you use this ABC button for a fraction. So I did 18 ABC 40, or 80. Okay, tangent to S. S now is the other acute angle, so the opposite of S would be this side. So 80 over adjacent, remember not over the hypotenuse, over the adjacent, so it's 18. So this one is 80 over 18. And that simplifies to 40 over 9 because it's the exact same one this one up here is. Okay, pause the video and try the ratios of B and of tangent K and tangent J, and then see if you got it right. All right, K looks like it would be 15 over 8, and therefore J is the other one, which would be 8 over 15. All right, and then the last section we are going to look at is calculating an angle, or calculate X, which is, sorry, not an angle yet. We'll do that later. A side length. So we're going to set up a tangent ratio equal to a degrees that it gives us. Here is the deal. If you want to do tangent of the 61-degree angle, because that's, we know we can't use the, you can't use the right angle. So it's either going to be this one or this one. If you use the one it gives you, tangent of 61, don't write this. I just want you to see what would happen. tangent of 61 equals, remember tangent is opposite over adjacent, so that opposite of the 61 would be 22 over x. And you can solve this equation. You can solve it when x is in the denominator. It's just a lot of moving around. You have to first multiply it by x, which we don't know. Multiply it by x, it moves over here. Then we have to divide by tangent of 61 because tangent 61x is being multiplied. So then you have to divide by tangent 61, and it's a lot. So I'm going to just tell you right now, if you notice that your variable is going to be on the bottom, if you know that in the tangent ratio, the one that you're missing is the adjacent, you might want to go from the other acute angle. It's less work. So remember how we talked about these add up to 180? This one's 90, this one's 61. So if you subtract from 180, that means that this acute angle is 29. And now I can set it up with opposite over adjacent and my variables in the numerator, which is going to be a lot less work. So let's do it like that. So we'll do tangent of our 29-degree angle. So tangent 29 is equal to opposite over adjacent, and opposite of that angle is x over adjacent is 22. This is going to be one step to solve and you're done. In order to get x by itself, right now it's being divided by 22, so you're going to multiply by 22 on both sides. That will cancel it out, and it will give us our answer. I think it's going to be about. So tangent 29 times 22. Take your calculator. Tangent 29, I'm going to push the tangent button. It opens a parentheses, 29. I'm going to close my parentheses, and then I'm going to multiply by 22. 12 point, okay, if we're doing a side length, you don't need to go 4 decimal places out. That's just if you're using the whole ratio. So we're going to call it 12.2 because all we're really looking for is a side length. So 12.2 is x. All right, pause the video and you try to come up with the length of x in this one, and then press play and see if you got it right. Okay, this one was already set up for opposite over adjacent, so all you had to do was tangent of the 56-degree angle equals x over 13. You had to multiply by 13 on both sides. Sorry, I thought I was going to have this worked out, but I didn't. And that would be tangent of 56 times what? 13. Okay, you should have got about 19.3. 19.3. Okay, the very last question is about elevation, angle of elevation. What you should know about the angle of elevation is that is a very specific angle. It's an angle, the angle is formed by a horizontal line. I'll show you that in just one sec. So it's formed by a horizontal line and a line, sorry, it's a little crooked, of sight up. So it's formed from the horizontal line and the line of sight going up to an object. So you're going to hear this probably a lot in trig because a lot of times they do angles of sight. Sorry, freeze the screen if I went too fast. I mean angle of elevation. But that would be you look for the horizontal line and then your eyes look up from there, and that creates an angle. So if you're looking at a horizontal line and it goes up from there, that is your angle of elevation. And in this problem, it points it out, but sometimes it doesn't. So always look for the horizontal line and then look up to what you're trying to see the top of. That becomes your angle of elevation, is the degrees inside from the horizontal line up to the line of sight of that object. So we're going to compute the height of the tree pictured on the right. It's really hard to see these numbers in here, but our horizontal line is our 45. It is a 59-degree angle of elevation, and the height of the tree is what is h. So that's what we're looking for. So this is a very easy tangent problem because our tangent of 59 degrees is opposite h, and our adjacent is the 45. So go ahead and freeze the video, pause the video, and try to come up with this answer yourself. Just do it like the last two we've done. All right, so this one I actually did work out ahead of time. You should have written it as tangent of your 59-degree angle is equal to your opposite over adjacent, which is h over 45, multiply by 45 on both sides, and that gives you a height of, I think it was 74 point something, but it probably wants us to round to the nearest whole foot, so I believe that is about 75 feet.